Hey everybody, and welcome to the next section on speed and velocity. Today's objectives: we're going to distinguish between speed and velocity, calculate the speed and velocity of an object, calculate the speed and velocity of an object from a position time graph, and distinguish between average velocity and instantaneous velocity. So the magnitude of the slope will tell us the speed of the object. The positive and negative sign tells us the direction of the object, while both pieces together tell us the velocity. If we go back to our Algebra 1 skills that we hopefully remember, right, we can find the slope of a graph by finding the change in the y divided by the change in the x-axis, rise over run. And when we apply this to a position time graph, we'll get the final position minus the initial divided by the change in time. And looking at our values on the axis, we have 7 meters minus 3 meters, which would give you 4, and 7 seconds minus 3 seconds, which will also give you 4. Now when we add and subtract units, the units will stay the same. They don't get affected or canceled out. Only when we multiply and divide them do we actually change the unit. And so when we simplify the math, we get 1 meter per second, which is also known as the velocity. So our first concept today is the velocity, which is defined as the change in position, aka displacement, in a certain amount of time. Our equation is shown here as displacement, or change in position, divided by the time it takes to change that position. The standard unit for velocity is meters per second, and our velocity is going to be a vector, so the direction the object is going must also be included. Now we're going to use a positive velocity as moving to the right, and a negative velocity as moving to an object moving to the left. So that's just the standard that we are going to be setting and using going forward. Velocity's cousin is called speed, something we're very familiar with in our everyday lives. Speed is defined as the distance traveled in a given amount of time, and its equation is given by s for speed equals d for distance divided by t for time. Our standard unit is also going to be meters per second. Now speed is a scalar because we're using the total distance traveled, so the directions of motion become irrelevant. Examples here. So we have 20 miles going at a speed of 50 miles per hour, and asking how long did the trip take you. So we got our distance 20 miles, speed of 50 miles per hour. We're going to use our equation, speed equals distance over time, and find time. We're going to manipulate our equation by multiplying by t to both sides and then dividing by speed in order to get t to equal distance over speed. Now, using this, we can plug in our numbers, 20 miles for the distance, 50 miles for the speed, and we get 0.4 hours in order for this object to travel that distance. In the second example, alright, we're traveling 55 miles per hour, that's our speed, for 6.2 hours, which is our time, and trying to find the distance traveled. Taking our equation, we're going to multiply time on both sides in order to move it over. Distance will equal speed times time. And then we're going to plug in our 55 times 6.2, and we get the distance to equal, we get 341 miles. So speed and velocity are cousins of each other, and the real difference between the two is whether we are factoring the displacement or the distance that the object travels. So if we have two cars that go from point A to point B, one car is going to travel that curved path and the other is going to go in a straight line. Now if they take the same amount of time in order to get from A to B, the one that takes the curved line has to go a noticeably bigger difference, meaning they must have a greater speed than the other car. Now even though it has a greater speed, the average velocity between the two, because they have the same displacement in time, they're going to have the same velocity. But one having to go a much greater distance is going to have a greater speed overall than the one that just travels in that straight line. In this next example, we're traveling 10 miles north in an hour and a half and 5 miles south in 0.75 hours. We're going to calculate the trip speed and velocity. So we go 10 miles north and 5 south. Always a good idea to draw a picture out. Now speed is going to be distance over time. Now our total distance is going to be our 10 miles plus 5 miles because we don't care about the distance, divided by the total time. So we're going to get 15 divided by 2.25, which will give us a speed of 6.67 hours. Or sorry, miles per hour. Now calculating velocity, we're finding displacement over time. Now our displacement is actually going to be only 5 miles north because we have to go up 10 and subtract 5. But we still account for the total time. So we're going to get 5 divided by 2.25, which is going to equal 2.2 miles per hour. Miles per hour. Alright, so what's the velocity of the runner based on our position time graph between 0 and 4, 4 and 6, and 6 and 8 seconds? Well, if we calculate the slope by finding the change in position over time, we can see that the slope of that first line is going to be 2 meters per second. The slope of the second line, which is horizontal or flat, means there's zero slope, so the runner was not moving 0 meters per second. Then that third line, which is negative, remember it's final position minus initial over the change in time, is going to give us negative 2 meters per second. So in this example, we're going to ask ourselves, who's running faster? Alright, the person who started at position 1 or negative 4. Well, remember, the speed and velocity depends on the slope. So the greater the slope, the greater the velocity. And that would be the person who starts at negative 4. Definitely has a much noticeable increased slope and definitely gets past that first runner pretty quickly. So here we're going to look at the difference between what we call average versus instantaneous velocity. Instantaneous velocity is how something is moving at a particular point in time, while the average velocity is the average speed over a given period of time. To indicate whether the following is an average or instantaneous velocity. So the speedometer on your car indicates that you're going 55 miles per hour. Well, that's going to be instantaneous, as that is the speed at a particular moment in time. A race car driver lists is going 140 miles per hour for an entire race. Well, that's going to be an average because it's over the course of a long duration. A freely falling object that has a speed of 19.6 meters per second after 2 seconds, well, that's going to be an average after a certain amount of time has occurred. Speed limit says 45 miles per hour will be instantaneous, as that is the speed at that specific moment.